Hello, let's continue our advanced Sudoku series with puzzle number 8 of chapter 2 of the Sudokult Gospel. Hopefully you know the drill by now, unless you're new to this series. But I know what technique I'm looking for, but not where it is. This allows me to make sure I properly find the technique that was intended for that this puzzle teaches, as well as so that I can properly explain it in case I don't know the technique. And so other than that, I don't know where it is. This is a live solve otherwise. I'm going to be hunting for it. And yeah, there's a link in the description to the entire Sudokult Gospel document if you want to try the puzzles yourself ahead of time. There's also a link specifically to this puzzle to solve in Sudoku Pad. And I'm going to get started right now. All right, we do have two 4s looking into this box. So 4 is in one of... 4 is placed. 4 is placed here because we have this 4 as well. 9s. Okay, 9's in one of these two. 5s. Join the 9s. So this is a hidden 5-9 pair. Okay. Anything else like look through here that's interesting? 8, 9, 4, 5. No. What about this 3? Okay, so 3's in one of these two, and that puts a 3 right here. What do we need in this box? We need 1, 2. Oh, we don't need 2. 1, 6, 7, 8. The 7's in one of these two, so that puts a 7 down here somewhere. Did I say 1, 6, 7, 8? The 8's up here. So this is only 1, 6. Okay. While I scan, I'm going to look for anything that might be kind of what we in the Sudoku biz call telegraphing when it comes to handcrafted puzzles, which is if there's an intended technique, sometimes it is telegraphed by, I don't know, in classics it's a little harder to see, but you can kind of get a feeling of like the placement of these givens feels intentional, so let's pay attention to that. So I'm gonna be on the lookout for that. Like this hidden 5-9 felt intentional to me. I'm actually on the hunt for some buy locals right now. See if we have any that look intentionally placed. I don't see it, so I'm gonna actually move on, and we'll hope for the best. Okay, these ones look in, this one looks down, so there's a 1 in one of these two. Oops, right there. 2's look into here. 2's in these 3. I'm not gonna mark 3 in this puzzle. I think it's just gonna clutter things. This looks intentional. This 5 needs to go in this row somewhere. So let's mark this buy local 5. I'll use green to designate that, hey, something special about these corner marks. And in this case, it's a buy local in the row. Buy local meaning there's 2 places in the row, right? Buy for 2, and local to the house. Buy value would be something like this, where a single cell is down to 2 values. Buy value. Okay. 7's are up here. Nothing like super exciting has happened yet except this 3 and 4. I guess this 3, we could put 3's here. Does this the 4 is done vertically and horizontally. The 9 doesn't do much. 7, 4. Okay, 4's in one of these two. Are there any like obvious buy values happening here? Or buy locals? We got the 5, which is nice. Okay, I'm gonna move on, I guess. I don't see what else we could mark here. 4 is not quite good enough in here. Okay, let's move on. I might be missing something, but we can always come back. Those 2's look in, so there's a 2 in one of those two. This being full could be useful. 4 is in one of these two. We need a 9 in this row, which is almost a... Oh, it is a buy local, actually. Yeah, I misscanned that. Okay, well, first let's scan these 9's and put a 9 in one of these two, and that makes it a little bit more clear that in this row, the 9 can't be here because of this 9. So it's only here or here. So I'm going to make that blue. No, let's use purple. Okay. So these 9's are buy local, and they're also buy local to this house. Or sorry, to this box. They're buy local to this row and to this box, like that. That's what I'm trying to say. 1 is in one of these two. Whenever we have like overlapping bilocals, it's always suspicious to me. Is 1 limited in this column? Unfortunately, we can put a 1 up here. So if we were to use this 1, it would have to be a weak link. Strong, weak, that could work. But then this is a strong link. So yeah, I don't think we've really built up any kind of useful chain at this point. So I'm going to keep scanning. 1 and 2 look in here. We got the 2s marked. 1 is in one of these 2. Okay, so this formation is going to cause bilocals both in the rows and the boxes, which could be useful. We also have this pattern, which is going to give us a bunch. So there might be something going on with 1s just because we have all of these bilocal 1s in the boxes, which also translate to being bilocals in the rows. Because 1 just doesn't have very many places to be placed in this area. That has in boxes where it hasn't been placed already. So that looks intentional too, although you never know. That can just happen naturally. So yeah, I haven't seen anything that's like, oh, this is an obvious, like, oh, like the corner is a buy value. That's suspicious. Like nothing like that yet. But we'll keep looking. Is there anything else horizontally here that I can do? Okay, no. I noticed this vertical. Whoops. So we have 1s up here. All right, let's go vertically here. 7 we got. Oh, I shouldn't have marked these 7s. I don't want corner marks that are 3. That's my mistake. I forgot what I was doing. Let's think about this column in general. What do we need? We need a 3, 4, 6, 7, 8. There's really not much going on with that. Okay. Anything else vertical that I want to look at, though? I think what I wanted to remember is that these couldn't be 7. I'm not sure how important that is at the moment. See, this can't be 1, 2, 3, 4, or 7. So it's 5, 6, 8, 9. Yeah, that's not that exciting. And then this one is even less restricted because it can be 1. Okay. Let's go vertically here. The 1s we got. We have 4s marked up. So there's bilocals on these 4s as well. And this 4 can connect to this 7 if we need it to. I'm not seeing anything else vertically here. Let's look over here. The 3s. There's a 3 in one of these 2. The 9s we got. What about these 4 digits? What do we need? We need 2, 5, 6, 7. So the 7 is over here. More 7s limited. So these aren't 7 now. Interesting. I don't think that does anything. This can't be 1, 2, 3, 7, 9. That's not that exciting. This is even less restricted. So the only thing that looked intentional was this 5 and maybe this 9, and then just in general these 1s. So I'm going to try to focus on that, but I don't see a great way to connect those yet. Is 6 somehow limited in this row? No, 6 isn't limited at all. All right, so I'm going to look for limited cells, and I'm also going to look for bilocals that I might have missed. Oh, there's a bunch of 2s looking into this box, which I somehow missed. So 2s in one of these 2. What do we need in here? We need 1, 2, 3, 6, 7. 1, 2, 3, 6, 7. Just so I don't miss anything else. I mean, the 1s, 2s, and 3s are marked, so it's really just 6 and 7, and I don't see any restrictions on 6 or 7 in this box. So it's not that. It's very suspicious, though, isn't it? This sort of cross pattern that we formed. Okay, what else can we do here? We thought about this box. I'm going to think about it again. 2, 5, 6, 7. Yeah, the problem is that 6s are just not... Is there even a 6 placed in this? There's not a 6 placed at all. 6 is missing. Which is absolutely possible. You can still be unique with one digit missing. If you have 2 digits missing, then everywhere that you could have placed those digits can be swapped. But if you're just missing 1 digit, that's perfectly fine. But in that case, that means unless I find a naked single 6, I am not going to have anything about 6s here. And that's going to mean every single cell is going to have 6 as an option until I do something about that. Is this 9 interesting? No, I looked at this before. It's not interesting at all. 1, 2, 7 in this row. We got the 1s, we got the 7s. The 2 doesn't seem interesting. Hold on. If these 2s are pointing, oh right, I have a 2 in this box. I was like, where's 2 in this box? I found it. 2's over here. Okay. Is there anything I can do? Let's see. What about 2's in this row? Because now, yeah, none of these can be 2. There, okay. So I missed that 2's are a buy value in this row. Whoa, I don't know what just happened. Okay. So 2's are a buy local in this row. Let's make that blue. Oh, and 1's. Yeah, because we have this 1 here. So I was thinking about how if the 2's could bridge the gap with this 1, and yeah. So the 1's are buy local here. Let's make that yellow. 2's to 1's. We could go down to this one if we want. I think that does it. Okay, let's pull out our pens. Okay, before I do the pens, let's get the I wanted to say instinctual. That is definitely not the right word, but let's get a good holistic understanding of how this works before we go into the rigor. There's a word I'm thinking of that isn't holistic and isn't instinctive, but means something similar. An intuitive. Let's get an intuitive idea of why this works before we start drawing things. Okay. So, and that also helps us think about the consequences. This cell, so 2 in this row. Let's talk about 2 in this row. I think that's the best way to talk about it. We're going to start here with these 2's. 2 in this row has only 2 options, right? So let's think about the 2 worlds that could exist. One world is that this is a 2. The consequence of that is that this cell's not a 2. And you're like, what? That cell? Okay, sure. The red cell's not a 2. In that world. There's one other world. Here, I'll make this red now. There's one other world, which is that this is not a 2. In the case that this is not a 2, the row needs a 2, it's going to end up here. But now the row needs a 1. That's going to end up here, because there's only one place for 1 left. Because we do have these 2 1s looking in, right? And this 1c's here. So that becomes a 1. Now in this box, actually, we can just go to the row. Now in this row, where does 1 go? Well, 1 in this row is in 2 places only. It can't be here because of this 1. It can't be here because of that 1. It can't be in these 2 cells because of that 1. And it can't be here because of that 1. So the red cell becomes a 1. You know what happens when the red cell becomes a 1? It's still not a 2. Right? So this cell can never be 2. The red cell there is no world in which the red cell becomes a 2. So we can eliminate 2 from the red cell. Is there anything we can eliminate from this cell? I don't think so, because in the other world, this is a 1, and this already couldn't be a 1. But it does eliminate 2 from this cell. So at the very least, that's what we want to conclude with more rigor. Although what I showed is logical. But we can use our strong and weak links to sort of get an intuitive understanding of why this is a wing, and maybe even think about where the pivot would be of this wing if we were to think of it like an XY wing, for example, or Y wing, however you want to call it. So we have actually, I should learn that straight lines look better. All right. We have a strong link here between these 2's. And if you, just a little bit of reminder, is that a strong link means that one of those 2 is true. They could both be true, but they can't both be false, right? One of these 2's must be true, and that's Sudoku rules, right? Because in this row, we need a 2 either here, or we need a 2 over here. Either way, that means one of them is going to be a 2. And in this case, exactly one of them's a 2. But the strong link only cares that if one of them gets eliminated, the other one immediately becomes true. That's what the strong link is telling us. A weak link, there's a weak link between this 2 and this 1. A weak link says both can't be true. They could both be false. One of them could be true. The other could be true, but they can't both be true. And so that's pretty obvious here why both can't be true, because they share the same cell. We can't have a 1 and a 2 in the same exact cell. So therefore, what that tells us is if this is a 2, this is not a 1. And alternatively, if this is a 1, then this is not a 2. That's what that tells us. So weak links are, strong links are stronger, right? they are more useful. But weak links make up the entire Sudoku rules, so they're important for sure. All right, there's a strong link between these 1's for the row. One of them has to be true. There is a weak link down to this one. If this one is true, that one's not. If this one's true, that one's not, because they share a column. And then there is a strong link between these ones. Now, and that's for the row. Now, if you recall, generically, we call something a wing if it has 3 strong links and 2 weak links. And look, we can count. We have 1, 2, 3 strong links and 1, 2 weak links. So what do we conclude from that? First of all, we can conclude that this is an alternating inference chain. We conclude that either this 2 is true or this 1 is true. We have formed a strong link. Let me use a different color here. We have logically devised this extra strong link. That is not a good color. I thought that would be a good color, but it wasn't. Let's just do I think let's actually avoid blue entirely. Let's do orange. Okay. We have concluded that this 2 and this 1 have a strong link. That's the conclusion of this, because if you can alternate strong, weak, strong, etc., and you end on strong, then you have formed a strong link between those 2 ends of your alternating inference chain. Just think about the 2 options. Either this 2 is not true, which then would come around making that 2, making that a 1, making that not a 1, making that a 1. So if 2 is not true, then 1 is true. That's one end of the strong link. If 1 is not true, then that we get the 1 here. That eliminates that 1. We get the 1 here. That eliminates that 2. That puts a 2 here. Just like how we had drawn this earlier. Except we use these 2 2s to prove that. But anyway. In that case, if this 1 is not true, this 2 is true. That's literally the definition of a strong link. So we can discover additional non-trivial strong links through the use of alternating inference chains. And when it's 3 strong links and 2 weak links, we can call that a wing. So let's think about this another way. Oh, sorry. Let's go to conclusion here. Because there's a strong link between this 2 and this 1, any weak links that are attached to both, any candidate that has a weak link to both of them, cannot be true. In that case, that's this 2. Because, let's go back to red here. This 2, I have to draw 2. This 2 has a weak link to this 2 because they share a column, right? And this 1 has a weak link to this 2 because they share a cell. Sharing a cell is how you change values usually, and sharing a column is how you preserve values, or sharing a row or a house in general. So hopefully that makes sense. I'm going to erase this little underline here. This little underline here. So what we have concluded here is that this 2 has a weak link to this 2, and this 1 has a weak link to this 2, and one of them must be true. Therefore, this 2 cannot be true, and we can eliminate the 2. All right, so let's think about this in one more way. We can think of it like how we thought about Y wings. And so the Y wing is you choose the pivot to be the middle strong link, because there's 3 strong links. You choose the middle strong link. So if we want to think about this like a wing, we think about this strong link here. So if this one is true, then this 2 is true. Otherwise, this one is true, which makes this one true, right? Because this row needs a 1. So that's our pivot. This is our pivot, and these are our pincers, right? The pivot is the 1s in these cells, and the pincer is this 1 and this 2. And no matter which one is true, this 2 cannot be true. So hopefully that's enough different ways of seeing this that you can kind of understand that. And so that eliminates this 2, and that lets us place this 2 in the box. And I'm hoping that's enough. I'm not sure what else we would find from this, because this 1 and this 2 don't have any other shared weak links that I can tell, other than the 1 in this cell, which is already eliminated, right? So normally we'd be able to eliminate the 2 from here and the 1 from here, but the 1 from here was already gone from the start of the puzzle. So hopefully that's what I was intended to find. So yeah, let's clear that out. And let's see. I think that's still called an L-wing because all the strong links were bilocal. It is a bit strange that we had to use a weak link within a cell, but I don't know if that affects the terminology of L-wing. They say it's an L-wing, so that's my guess. But anyway, so what does this 2 get us? This 2 looks in. Is that enough? Better be. Because I think that was it. All right, let's see what's the consequence of finding this 2. How about this column? What is this? Oh, this column needs a 9 now. Oh no, that's down here. The purple confused me. I misscanned because of the purple. What do we need here? We need a 5, 6, 7, and 9. These can't be 7. Ah, so when this 2 got filled, remember we had a 7 down here that I didn't want to mark because it was in 3? Now this is a 7, 9 hidden pair. That seems important. So I don't need this corner marked to 9 because it's part of a pair. And so now this is going to be a pair. What was it? I forget already. 1, 2, 3, 4. We need 5 and 6 here. And those are placed. Very nice. Okay. And now this isn't a 5, so we can follow our buy local and place that 5 and get rid of our green. Okay. So just taking it slow so I don't mess up, but this cell is missing the 1 and 3. So what do we need in this box? We need 1, 2, 3, and 8. So this can't be a 2 either. So this is a naked 8. These are from 1, 2, 3. This can't be the 1 or the 2. So this is the 3. And I think we're left with a 1, 2 pair here. But this 3 does give us this 3 as well. Okay. I'm thinking, okay, I was trying to see what I wanted to follow up with. Let's do this first. So we need a 4, 6, and 8. 4, 6, and 8. I'm just going to write it out because I think it's just this 4. I think it is. Okay. This triple might be helpful, and we need a 3, 6, and 9. 3, 6, 9. So this can't be 3, 9. So this is a 6, which definitely seems like it should be helpful. There's a 6 over here. And then this was what, 3, 9? It's a 3, 9 pair. So these are 4, 7, 8. Can't be 8, can't be 4. I don't think I need these corner marks anymore. Let's see. We need the... I'm looking at what else we need. We need a 9 in this row. So 9 is over here. And in general, yeah, we need a 7 in the row, which goes over there. I think I literally just removed those 7s, but anyway. So what is this? This is 4, 8, 9 or something? This one's not 4? Okay. How about this row? This row needs a 2, 5, 6, 7. Well, this can't be 5 or 6, so this is 2, 7. This can't be 2, so this is 5, 6. Oh, it can't be 5 either, so this is 6, 7. 2, 5, 6, 7. This is 2, 5, 6. This is any of them? I'm missing something important. Okay, let's try to follow up on things we've gotten. We got this 7, 9 pair. So that leaves a quad in the box. What is the quad? It's a 1, 5, 6, 8. So the 8 is in one of these two. So this is only 5, 6. 5, 6, 8. I'm not really seeing what else to do with 1, 5, 6, 8 though, because 5, 6 can go anywhere in this box. Okay, was that helpful? Maybe this column. What does this column need? It needs a 4, 6, 7, 8. No. Not helpful at all. This can't be 4. How about up here? We need a 1, 6, 7, 8. This isn't 7, so this is 1, 6, 8. 1, 6, 7, 8. It's any of them. Clearly I'm missing something. How about this box? We need a 2, 5, 6, 7. So this is also... Oh, it can't be a 2. So this is from 5, 6. Oh, and the 5, 9 pair does make this a 6. Okay. So we're down to 2, 5, 7 here. That's not a 5. This is not a 6. 2, 5, 7. So 6 in this column is down here, I guess. This column has 5 open cells. We need 1, 2, 4, 7, 8. The 8, nope. The 4, no. Wait, 4 and 8. Yeah, 4 and 8 don't go here. So this is a hidden 4, 8 pair for the column. And so then this is a 1, 2, 7 triple. Okay, that should be helpful. So this is a pair. We do need the 3. What else do we need? The 6. We need a 3-6 pair there. Perfect. 3-6 pair. Yeah. Okay. Ever since we got this 6, that was there. All right. And so that makes that a 1. And that resolves everything, I think. Because this can't be a 1 now. 2-7 pair makes that a 1. So I don't need the yellow here anymore. It's not a bilocal anymore. There. That places this 1 and this 9 through our purple bilocal. So that's not a 1 anymore. That places the 1 in this box, and the 6, and the 7. Gets us the 2 and the 1. Gets us the 7, 5, and 2. That places the 2 for this row, and that 7. Gives us the 6 and the 7 here. All right. Using our bilocals that we had from the start. Here's that 8, 9, 4, and 6. That's a 4, 7, and 8. We get the 8 here, the 4 here, the 8 down here. This is whatever the box is missing, a 5. What does this box need? It needs a 5, 6, 7. So, okay, all I'm seeing is the 7 looking down at this cell. Whoa, whoops. 5, 6, 7. Oh, there's this 5 here too. All right, that's not what I'm supposed to find. How about this? This is 6 or 7, but it's not a 6. So that's 7, that's 6, that's 5, that's 7. There we go. We get the 3 and the 6. We get the 9 and the 5. We get the 9 and the 3. And then let's play what does this box need? It needs a 4, which goes there. They should all be singles. It needs a 5. It needs a 6. It needs an 8 and a 9. And we're done. All right, well, that took longer than I expected. I thought this was a shorter solve, but I guess I was having fun. I did spend a long time explaining the wing. So that I wonder how much time I actually spent on that, because I said it at least 3 or 4 different ways. Really hoping it becomes, if you find some way that you can understand it and find it, then that's the goal of this series. It's not to show my prowess in solving these fast. It's intended to be helpful, and I hope it was. I enjoyed this. I think that this was a neat wing using this pattern, and really it just eliminated one candidate, but that was enough to just collapse the whole puzzle. Getting this 2, that was enough. That was really cool. And yeah, this is a neat formation here, with the bilocal strong links changing digits through this cell. Always neat. So yeah, I hope you enjoyed this as well. And if you did, then why not leave a like, subscribe, and a kind comment below.